Infusion tube structure. According to statistics, around 80% of patients are supplied with medication intravenously during hospitalization. But the structure of the infusion tube is not good enough, which will result in blood backflow, residual air, and inaccurate adjustment of the number of drops. Infusion tube structure. In this innovation, we focused on 3 elements for design improvement: a Y-shaped backflow prevention structure, injection port, and flow rate adjustment device. The main structure of the infusion tubing includes the following: a Y-shaped backflow prevention device which includes an elastomeric umbrella valve, a valve seat, an aperture, a main tube, a branch tube, a sealed column, an upper adapter opening, a lower adapter opening, etc. An injection port includes a syringe port seat, a syringe port base, a valve, an incline plane, an aperture, adapters, etc. A flow rate regulation device includes a cassette, rollers, a guiding groove, a slide knob, etc. The Y-shaped backflow prevention device, due to gravity and the height, the IV fluid exerts pressure downwards on the elastomeric umbrella valve, enabling the delivery of the IV fluid into the vein through the aperture. In contrast, when the peripheral venous pressure rises, the pressure of the fluid flowing backwards in the infusion tubing will push the elastomeric umbrella valve back against the valve seat, sealing the aperture and hence avoiding blood backflow. By withdrawing with an empty syringe via the branch tube, it can be checked whether the catheter is still retained in the vein. Moreover, the branch tube can also be used as a route for IV push medication. The injection port, the adapter, is connected to the infusion tubing in a 180 degrees angle, avoiding the generation of an empty space within the port base to prevent air from rushing to the space during the infusion tube air removal process, and saving the trouble of the flicking of the tubing. Pushing the piston of the empty syringe towards the syringe port forces the inclined surface of the valve body to move, prompting the aperture open, which enables the drug solution to enter the human body through this route. When the empty syringe is pulled out after the administration, the incline plane returns to its original state and the aperture closes immediately, reducing the chances of air entering the human body. Flow rate adjustment device. The slide knob is used to control the movement of the rollers on both sides of the cassette in the guiding groove to increase or decrease the pressure on the infusion tubing for precise flow rate regulation. This innovation possesses 6 features: 1. Usage safety. 2. Air removal process smoothness. 3. Air removal process efficiency. 4. Simplicity and effortlessness. 5. Operation convenience. 6. Nursing practice efficiency.